will discuss the dissonant pattern of latent polarity. So dissonant pattern usually occur in 1,2 disubstitution or 1,4 disubstitution compound. Okay, so in dissonant pattern, it involves target molecule that undergo disconnection will give syntons of unnatural polarity, or we also know it as ompolong syntons, and the forward synthesis usually require ompolong synthetic equivalent or reagents, which is not like a typical reagent. Okay, what is the difference between dissonant and consonant is that when we have two oxygen here, okay, the charge at the carbon is different. Okay, in this case, this C double bond O, it is plus, but another C double bond O is minus. So when we have different latent polarities like this, so it is what we required as ompolong synton. Okay, if we look at the example here, if we have diketone compound like this, and if we were to disconnect at this part, at this point, so what we get is two syntons, which is one is the negative synton and one is the positive synton. In the case of negative synton, we usually neutralize this negative using hydrogen. So our synthetic equivalent is ketone and also base as a catalyst. Yeah. And then what about the positive pair? So what is the correct equivalent for this synton? Okay, so since it is positive, so we need to balance it with negative atom. So in this case, we can complement the synton by adding bromine atom to the compound. So what we get is this is plus and the bromine is minus. So this is the synthetic equivalent of that synton. So how we go about it is this reaction. We can use this reaction where we have base. So the base will abstract the alpha proton here, and then this will become CH2 minus. So the CH2 minus here is the nucleophile, which will attack this carbon, partially positive carbon, and the bromine will leave the molecule and result in 1,4 disubstituted compound. 1, 2, 3, 4. Okay, we can look at another example where we have a ketone, diene plus ketone. So how are we going to make this compound? Okay, first step require us to do FGI, meaning whenever we have double bond, we need to convert it to OH first. So this will undergo a process that is known as FGI. Okay, so we will get the alcohol. Okay, once we have the alcohol, we need to break this molecule into two syntons. So in this case, this is the plus synton and this is the minus synton. Okay, so in this case, this is the retrosynthetic analysis, and now the forward reaction. So what happened if we have acidic proton here? So when we have a base, so this is the base. So this is the base. So what happened is that this base will abstract the proton, and then this bond will abstract the proton, and then we will have CH2 minus. So CH2 minus, CH minus here is a nucleophile, so it will attack this carbon. Okay, and then it will give us this compound. Okay, and then this alcohol, it will undergo dehydration to give the target molecule. Okay, these are some of example on the 1,4-disubstituted carbonyl compound and 1,2-disubstituted carbonyl compound. Okay, let's take a look at the 1,4, 1, 2, 3, 4. So if we look at the charge, the polarity, it is not the same. So normally in this case, when we disconnect, it will result in one normal synton and one ompolong on unnatural synton. In this case, the normal synton is usually an ester, and the unnatural synton is a carbonyl compound having halogen substituent. So this is ompolong synthetic equivalent. This is not normal. This is not natural one because it needs to be synthesized to make this compound. And then when we have 1,2-disubstituted carbonyl, we can see that at carbon number 1 it is plus, at carbon number 2 it is minus. So when we break the molecule, we will get one normal synton and another one is ompolong synton. Okay, so for normal synton, it is equivalent to acid chloride, while ompolong synton can give us something like cyanide ion. Okay, that's all for latent polarity. So in the next video, we will show you how to solve problems related to this topic.